All right, so in this video, we are going to be looking at the example that's on the back, or it's on actually a separate page of your notes. And this problem has several pieces to it, even though it's really related to just one function. So we're going to concentrate on the new piece, which is finding points of inflection first. And so we'll have to do the derivative. And so f prime is equal to, so if you bring the 4 times the 1/4, that'll be a 1. And then your exponent will become 3. So x to the third minus, and then your 2 will be brought down, multiplied by your 2x, and you'll have 4x. So f of x equals, or f prime of x equals x to the third minus 4x. We will come back to finding critical numbers with that a little bit later on. I'm going to go ahead and concentrate just on finding the points of inflection. So we'll do f double prime. And so for f double prime, we'll have 3x squared minus 4. So hopefully you see these as relatively easy derivatives to do. To find your points of inflection, we will look first of all for where f double prime is equal to 0. And so 3x squared minus 4, setting that equal to 0, you could add 4 and then divide by 3 and get x squared equals 4/3. And then square root both sides. And remember, when you square root, that you get plus or minus. So that would be plus or minus 2 over the square root of 3, which, if you rationalize the denominator, would be 2 square root 3 over 3. So you've got your 2 x values. And I would call these possible points of inflection. You really need to know what's happening before and after. So these are possible x values for the points of inflection. And again, I'm referring to those as POIs. And so if this is the goal for you to find the points of inflection, then you can build a table that has your intervals established by these possible points of inflection, and then your sign of f double prime and your conclusion. And I do want to say, even though this is clearly not going to have anywhere where f double prime is undefined, but you should always check for f double prime being undefined if you have that as a possibility. So be sure that you check that, especially those functions that have numerators and denominators. You'll need to check that, because those also are indicators of possible points of inflection. So if you are asked about concavity or about points of inflection, you'll need to build a table. And since this is a polynomial, we'll start at negative infinity, and then you'll go to your first leftmost point of inflection possibility, so negative 2 square root 3 over 3. And then you'll look at what's going on at that possible point of inflection. So x equals negative 2 square root 3 over 3. And we'll just continue on as much the same as what you had to do with the first derivative. So between your two possible points of inflection, we'll look at that interval as well. We'll look at what happens at that positive 2 square root 3 over 3. And then finally, we'll take a look at our last interval. Well, having a little trouble getting that to move up. Okay, there we go. And then 2 square root 3 over 3 to infinity. Now, I did go ahead and check out what that decimal would be. So the decimal for 2 square root 3 over 3 is 1.15. So 1.15. So as we look at choosing a number between negative infinity and negative 1.15, you could use -2. You could use, any number you want to. So if you didn't know what -2 square root 3 over 3 was as a decimal, you'd want to use something safe like -10 or some number that you know is definitely between negative infinity and that number. So remember that just like we did with the first derivative test, you'll take that number in your interval. This time, remember that you're substituting into the second derivative, so into 3x squared minus 4. So for example, I'm using -2. I'll plug in -2 for the x. So 3 times -2 squared minus 4. Remember, I'm only concerned about whether this is positive or negative. So -2 squared is going to be positive times 3. That's actually going to be positive 12. And then subtract 4. This is going to give me a positive answer. And I'll have a positive sign of f double prime in that interval. I'm going to now choose something in between -2 square root 3 over 3 and positive 2 square root 3 over 3. 0 is an excellent choice. So I'll use 0. And once again, I'm looking for just the sign. So 3 times 0 is 0. 0 minus 4 is going to be negative. And so it's negative in that interval. And then you can probably guess, hopefully from the symmetry of things, that I'll use positive 2 as my number that is in between 2 square root 3 over 3 and positive infinity. And again, because of symmetry, hopefully you'll see that that is going to be a positive. So this is my sign of f double prime. Now, I called this conclusion. I think that's something I used to have in the past, but I think a better title for this, and I forgot to change it, would be the characteristic, as we've been saying. So the characteristic, I may not be able to squeeze all that in. I'm just going to abbreviate. The characteristic of f. And so when your f double prime is positive, then f is concave up. And as you are going through your homework, if you want to abbreviate that CU, that's fine. This is a table for your information. So just make sure that you know what that stands for. And then concave down would be our next conclusion, since the second derivative is negative. And then since the second derivative is back to a positive, we have concave up in that last interval. And then if you want, or if you're required to, the sign of f double prime for those possible points of inflection, those were both zeros. Those were what made the second derivative equal to 0. And then now, because we had a sign change, we went from positive to negative, and it doesn't really matter on this one which one comes first, just that you do have a sign change. So since there was a sign change from positive to negative, Then we have a point of inflection, and its ordered pair would be negative 2 square root 3 over 3. And then you have to substitute negative 2 square root 3 over 3 into the original function. I'm not going to take the time to do that math. I'll let you use a calculator to get that done. The fraction turns out to be negative 20 over 9. So your ordered pair would be your x from the possible point of inflection and then negative 20 over 9. You also have a sign change going from negative to positive. So you have another point of inflection. And remember, this is what you were being asked to find. I think now I'm going to get rid of this writing. Might make this a little bit clearer to you. And so the ordered pair, again, is positive 2 square root 3 over 3, and then positive 20, or excuse me, negative 20 over 9. So in just a little bit, I'll be doing a video where we will graph the function. We've got a little bit more to find out about it, and I'm going to do that in a separate video. We've got to find the relative extrema, and for that I'm going to do the second derivative test, but we will use this information about concavity as we draw the graph of this function. So keep in mind that we will be plotting the 2 points of inflection and taking note of whether the graph is concave up or concave down. So this is the end of this video. You should use this one whenever you are asked to find either where a graph is concave up or down, or if you're asked to find the points of inflection.